You ever wondered why you can sprint for only a few seconds but walk for hours? It might seem obvious that higher intensity exercise is less maintainable, but the real answer lies in our body's three energy systems and how they fuel different activities. In this video, I'll break down how these systems work together to power everything we do. All the energy our bodies use comes from food. Macronutrients are metabolized to create adenosine triphosphate, ATP, the primary energy currency in cells. ATP fuels cellular functions like our focus today, muscle contraction. When there's excess ATP, the liver converts it into glycogen, a form of glucose stored in the liver and skeletal muscles. Let's see how these energy systems play out. Short bursts like sprinting or weightlifting rely on the ATP-PC or creatine phosphate system, which provides immediate energy for about 10 to 20 seconds of high-intensity effort. Once ATP stores are depleted, it takes about 3 minutes of rest to replenish the desired amounts. For medium intensity activities lasting 30 seconds to 2 minutes, the glycolytic system kicks in. Remember when we talked about glycogen synthesis? This system breaks down glucose or stored glycogen into pyruvate to produce ATP. Without enough oxygen, glycolysis generates lactic acid, which causes the burning sensation in muscles and contributes to fatigue. Now, longer, sustained activities rely on the aerobic system, which produces the majority of ATP. An increase in heart rate allows the body to take more oxygen in. The energy release comes from a diverse mix of interactions within your body, including glycolysis, reactions within cells and mitochondria, and the breakdown of nutrients such as glucose, lactate, and fatty acids. It uses fat as its primary energy substrate, producing enough ATP to sustain longer duration activities, but only at a submaximal exercise output. So it has the slowest ATP production rate, but is highly efficient and sustainable for hours if fuel stores are sufficient. Why does this matter? For athletes, training the right energy system is key to improving performance. For everyone else, different intensity levels benefit overall health. Aerobic exercise supports cardiovascular health, while anaerobic exercise builds strength. With obesity becoming a major health concern, understanding how our body processes macronutrients also shed light on how excess carbohydrates are stored as fat. When ATP and carbohydrates are in surplus, the pyruvate produced during glycolysis is in turn used to synthesize fatty acid, and these molecules result in the synthesis of fatty acids within the body. These acids are stored in adipose cells, the fat cells whose primary role is to store fat for later use, which just reiterates how to truly unlock your potential and optimize your health, it's essential to recognize how these systems work in harmony to support your body's every move. Our bodies are incredible and constantly adapt to meet the demands we place on them. By understanding these energy systems, we can train smarter, fuel our bodies better, and appreciate the complex science behind every step we take. Whether you're an athlete or just curious about how your body works, these energy systems are at the heart of what keeps us moving. Thank you for listening.